So here we have to find out the equation of a circle, which is formed whenever we take another circle with center given by a comma a and radius a. It's rolled along the positive y-axis for one full revolution. So let's try to understand this particular problem. So let's consider the xy Cartesian plane, and here we have the x-axis and the y-axis. We'll begin by considering a circle which has a center at the point a comma a. So let's assume that the center of the circle is at this particular coordinate point with coordinate a comma a. So this would mean that the y coordinate value is a and the x coordinate value, so that's also equals to a. And since the radius of the circle is given that it's also equals to a, that's very evident, then this circle must touch the x as well as the y axis. So here we have the circle. Now what is being done is we are going to roll this circle in the positive y-axis and is going to go for one full revolution. Now, in order to make it go along the positive y-axis, it's necessary to rotate it in the anti-clockwise fashion. So this is going to rotate, and after one complete revolution is going to reach a new location. Now it's clear here that the circle is at a new location, so its center is going to shift. Now earlier, if we consider the center to be at C, the new center, let's consider it to be at C prime. So we'll have to find out the coordinate of this new center. Now it has undergone a revolution, one full revolution. Now here the x coordinate is going to remain unchanged because it is still going to touch the y-axis. So here the x coordinate is going to remain as a. Now what about the y coordinate? So initially it was at a distance from the x-axis. Now after it has undergone one full revolution, it has moved by 2 pi r amount, that means by the circumference amount. So that means this length c prime to c, this length will be equals to 2 pi times the radius of the circle, which is 2 pi times a. So that is the length that it has covered up. So the total length will be, initially it was a, and to it we're going to add the circumference, which is 2 pi a. So that's the coordinate of the circle, and the radius is going to stay fixed at a. So now that we have the new coordinate of the center as well as the radius of the circle, we can easily determine the equation of this new circle. So for this, we're going to use the standard form of a circle. So here we have a circle whose center is given by the coordinate h comma k, and it has a radius of r. Then the equation of the circle is given by x minus h whole squared plus y minus k whole squared equals to r squared. So this is the standard equation of the circle. Now in our case, we already have the center. So our center, which is h comma k, we found out that this value equals to a and a plus 2 pi a. This immediately tells us that the value of h is going to be equals to a and the value of k is going to be equals to 2 pi times a. And the radius is also fixed, so the radius is a unit. Now we can use the standard form of the circle. We're going to get x minus h whole squared plus y minus, the k is 2 pi a plus a, y minus 2 pi a plus a whole squared equals to the square of the radius. So that's going to be the equation of the circle.